In problem number 14, we are looking at a function, n of t, which is the measles pathogenesis curve, which gives us the approximate number of infected cells per milliliter of blood plasma t days after contracting the virus for a typical patient. And what we are asked to calculate is the total burden of the infection. Now, the total burden of the infection over the period of the first n days of the illness could be measured as the area under this curve. And the problem is asking us to calculate the threshold burden of the infection needed to develop symptoms. Now, typically the symptoms for measles appear on after 12 days, and so this threshold burden that we need to calculate is the area under the pathogenesis curve over the interval from 0 to 12. Now, of course, this we can calculate this area as the definite integral. Since we're given the equation for this curve, n of t equals negative t cubed plus 20t squared plus 21t, we can calculate the burden, that threshold burden, as the integral from 0 to 12. Now, the reason we're integrating from 0 to 12 is because we're told that the symptoms usually appear after 12 days, and so that's the total burden experienced in the first 12 days is what is needed to experience symptoms. And we integrate our function, negative t cubed plus 20t squared plus 21t dt over the interval from 0 to 12. This is a simple integration. We integrate the function term by term using the power rule to find the antiderivative, negative t to the fourth over 4 minus 20 times t cubed over 3 plus 21 times t squared over 2. This is the antiderivative. We do not need to add integration constant. Also, please note that after I've integrated, I do not write the integral sign anymore. In your work, I noticed that some of you continue to write the integral symbol after the antiderivative has been computed, so that would be misleading and incorrect. The integral sign means that we are integrating. So, for example, right here, when I put the integral sign right here, it tells whoever is reading this that basically we're integrating the expression that is that follows the integral sign between that is located between the integral sign and dt, the differential. Now, what I see a lot of you do is you integrate, you found this antiderivative, but you still keep that integral sign. And that would be incorrect because it would further instruct whoever is reading this to further integrate the antiderivative that you just found. And so that's not what we want. What we want to do is, now that we've found the antiderivative, we want to evaluate this antiderivative at the endpoints of our interval of integration. So in other words, we want to plug in, instead of t, 0 and 12, and then we want to take the difference of the resulting values. Now, when we plug in t equals to 0 into this formula, we're going to get 0. So the only thing that we need to really calculate here is the value when t is 12. And so we're going to get negative 12 to the fourth over 4 minus 20 times 12 cubed over 3 plus 21 times 12. I think I mistakenly put a negative sign for the term, for the square term in the function that we need to integrate. I'm talking about this term right here. In the given function, there was a positive term, so I made a mistake, typo. Let me correct that. It should be positive. Correct the sign everywhere below as well, so it's actually plus right here. And then plus, finally, 21 multiplied by 12 squared divided by 2. Now use a calculator to calculate what this is, and that's going to be our answer. Let's open the calculator. Minus 12 raised to the power 4 divided by 4 plus 20 times 12 to the third, all divided by 3, plus, let's see what the last term was. The last term was 21 times 12 squared over 2. And we find that this integral equals to 7,848. And that is the correct answer for this problem. 7,840.